Hi dear friends, welcome back to our channel Vinay Kumar Basics of Physics. This is the right place to learn. Dear friends, in this video we are going to discuss about the one of the most important question for 4 marks, that is in the chapter of electric charges and fields. Electric charges and fields అనే చాప్టర్లో ఒక 4 మార్క్స్ క్వశ్చన్ మనం డిస్కస్ చేయబోతున్నాం. దట్ ఈస్ మోస్ట్ ఇంపార్టెంట్ ఫర్ 4 మార్క్స్ చిల్డ్రన్. సో డియర్ ఫ్రెండ్స్, in our channel I am uploading all the videos related to the intermediate second year physics and first year physics also. Along with them I am going to upload the MSET videos and NEET videos in this channel. That's why you have to subscribe my channel and press the bell icon to get all the notifications. Bell icon press చేస్తే మనకి ఆటోమేటిక్గా నోటిఫికేషన్ మీకు వచ్చేస్తుంది. సో కాబట్టి నా ఛానల్ ఖచ్చితంగా ఫాలో అవ్వండి, రెగ్యులర్గా మీకు ఖచ్చితంగా హెల్ప్ అవుతుంది. ఓకేనా? వితౌట్ లేట్ ఐఎమ్ గోయింగ్ టు ది టాపిక్. డియర్ స్టూడెంట్, ద క్వశ్చన్ ఈజ్ షుడ్ బి లైక్ దిస్. Derive an expression for the intensity of electric field at a point on the axial line of electric dipole. Derive an expression for the intensity of the electric field at a point on the axial line of the electric dipole. సో ఎలక్ట్రిక్ డైపోల్ యొక్క యాక్సియల్ లైన్ మీద ఒక పాయింట్ దగ్గర ఉన్నప్పుడు ఆ పాయింట్ దగ్గర ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ ఎంత ఉంటుంది, దానికి ఈక్వేషన్ మనం డెరైవ్ చేయాలి. సో బిఫోర్ గోయింగ్ టు డెరివేషన్ యూ మస్ట్ నో అబౌట్ ది వాట్ ఈస్ an electric dipole. What is an electric dipole? Dipole is nothing but if two charges of equal magnitude and opposite charges are separated by some distance, then it is called an electric dipole. ఏవైనా రెండు చార్జెస్ అవి వాటి యొక్క మ్యాగ్నిట్యూడ్స్ ఎలా ఉండాలంటే సేమ్ ఉండాలి అండ్ దే ఆర్ సపరేటెడ్ బై సమ్ డిస్టెన్స్, దెన్ దట్ ఈస్ కాల్డ్ an electric dipole. Look here, two equal and opposite charges are separated by some distance, then it is called dipole. This is a minus q and this is the plus q. They have equal charges and opposite charges, then now it is called an dipole. What it is called? Electric dipole. Here simply this is the midpoint of the dipole. Here that is the midpoint of the dipole, and now from here to here we will take, that is the A, and this is also A. That means the distance from center of the dipole to the every charge is same, and here 2A is taken as the dipole length. The distance between the two charges can be taken as the dipole length. So children, this is simply about the electric dipole. That's the first thing you have to remember. And the second thing is dipole moment. What is dipole moment? Dipole moment is nothing but P is equals to 2A into Q. P is equals to 2A into Q. What is 2A here? I already just now told you what it is. 2A, length of the dipole. So length of dipole into, and what is Q? Magnitude of charge. Here the product of the length of the dipole and magnitude of charge is called dipole moment. What it is? Dipole moment. Dipole moment P is equals to length of the dipole 2A and magnitude of charge Q. That is what? Dipole moment. So 2A into Q. So here what is 2A? Length. And what is Q? S, charge. And now units are simply what, right? Coulomb meter. Coulomb meter is the unit for dipole moment. So next thing is children, we have to know about the axial line. Children, in 4 marks answer, 1 mark should be awarded for the definition of axial line. What is the axial line of a dipole? An imaginary line that should be passes through the two charges of a dipole, that should be called an axial line. A horizontal line passes through the two charges of a dipole is called an axial line. ఒక డైపోల్ తీసుకున్నప్పుడు ఆ డైపోల్ గుండా టూ చార్జెస్ గుండా ఒక హారిజంటల్ లైన్ మూవ్ అయితే దాన్ని మనం యాక్సియల్ లైన్ అని అంటాము. లుక్ హియర్, దిస్ ఇస్ ద డయాగ్రామ్. minus q plus q, it is two charges are separated by some distance, that's why it is dipole. And here we are showing some dotted lines. That line is passes through the two charges of a dipole. That's why it is called axial line. Clear? Now we have to find out the electric field intensity at a point on this axial line. So derivation is very important, children. Let's go for that. Children, now we have to find out the electric field intensity at a point on the axial line. Clear? So children, look at here. This is the one dipole, minus q and plus q. Dipole of length 2a. Clear? 2a is the length of the dipole. And we are selected the point P that should be on the axial line. This is the axial line. On that axial line, one point is there, that should be what? P. And that should be at a distance of small r from the center of the dipole. Clear? At a distance of small r from the dipole, that is the point here P. And where it is point? Axial line. So here dipole length is 2a and the distance from here center of the dipole to the point is what? Small r. Clear? Now at this point P, we have to find out the electric field intensity. E P అనే పాయింట్ దగ్గర మనం ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ ఫైండ్ అవుట్ చేయాలి. క్లియర్ చిల్డ్రన్? హియర్ ద పాయింట్ P is in the combined field of the minus q and plus q. Combined field of the minus q and plus q. That's why here there is some electric field intensity because of plus q at the point P, and there is some electric field due to the minus q at the point P. Clear children? So మనకి P అనే పాయింట్ అనేది మైనస్ క్యూ ప్లస్ క్యూ యొక్క కంబైన్డ్ ఫీల్డ్లో ఉంది. కంబైన్డ్ ఫీల్డ్లో ఉన్నప్పుడు మనకి ఈ P అనే పాయింట్ దగ్గర ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ అనేది ప్లస్ క్యూ ఛార్జ్ వల్ల ఉంటుంది, అట్ ద సేమ్ టైం మైనస్ క్యూ ఛార్జ్ వల్ల కూడా ఉంటుంది. సో ఆల్రెడీ వీ నో దట్ చిల్డ్రన్, వాట్ వీ నో, ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ due to a point charge, due to a point charge, what we know, E is equals to 1 by 4 pi epsilon naught q by r square. This is a general equation you have to remember, electric field intensity due to a point charge. In the same manner here, so what we know, we have some formula, it is there. Look here, E is equals to 1 by 4 pi epsilon naught q by r square. What is the r? Distance from charge to the point. In the same manner, what I am telling, at this point P, electric field intensity is there because of plus q. That should be given by electric field intensity at P due to plus q charge. What is plus q charge is given by the formula like this. Already what we know, E1 is equals to 1 by 4 pi epsilon naught. What is the charge we are taking? Plus q by distance. How much? Charge నుంచి point P and distance ఉంది, that is BP whole square. We can write E1 is equals to 1 by 4 pi epsilon naught plus q by BP squared. So in that figure what we write, this is the R and this is the A. Clear? So this is the R and this is the A. So BP means what, right? In the from figure we have to write R minus A. మనకి ఇక్కడి నుంచి ఇక్కడ కావాలి, సో దీంట్లో నుంచి మనం ఏం చేస్తున్నాం, A ని తీసేస్తున్నాం. కాబట్టి ఫ్రమ్ ఫిగర్ వాట్ వి రైట్, BP is equals to R minus A. Therefore E1 is equals to 1 by 4 pi epsilon naught q by what is BP? R minus A whole square. This is the equation number 1, and it is in the direction of, E1 is in the direction of, so for positive charge what you have to say, the electric field is radially outward. That's why here what we write, E1 is in the direction of BP. So BP ఏ డైరెక్షన్ లో ఉందో E1 కూడా అదే డైరెక్షన్ లో ఉంటుంది. This is the equation about the electric field intensity due to the plus q charge. And in the same manner here we are going for second one like this, the electric field intensity the electric field intensity due to the negative charge or minus q, due to the minus q is given by సేమ్ ఇదే ఫార్ములా చేసుకుని రాస్తున్నాం. దాన్ని మనం E2 అంటున్నాం. వాట్ ఈస్ E2 అంటున్నా. E2 ఈస్ ఈక్వల్స్ టు వాట్ హ్యావ్ టు రైట్, ఎస్ వాట్ హ్యావ్ టు రైట్ 1/4 pi epsilon naught and minus q by what is the distance from q to p, nothing but what it is AP. So AP whole square minus q charge నుంచి ఆ పాయింట్ p కి డిస్టెన్స్ ఎంత AP whole square. So again what you write children, from figure we can write what is AP. AP is what, this is the R, here to here R and here to here A. So kabatti what you write, AP means what, R plus A whole square. That's why what you write, E2 is equals to 1/4 pi epsilon naught minus q by R plus A whole square. R plus A whole square. This is the equation number 2 children. So this is equation number 1 and this is the equation number 2. So children, board is not much spacious. That's why మనం కంటిన్యూషన్ డెరివేషన్ పోవడానికి ముందు మీరు ఖచ్చితంగా ఇది నోట్ చేసుకోండి. నోట్ చేసుకున్న తర్వాత మనం కంటిన్యూషన్కి వెళ్తాం, ఓకేనా. సో ఇక్కడ E2 ఈజ్ ఈక్వల్స్ టు వీఆర్ రైటింగ్ 1/4 pi epsilon naught minus q by R plus A whole square, and it is in the direction of this is a minus q charge. That's why the electric field is radially inward. So towards like this in the direction of what you have write PA. E2 అనేది PA డైరెక్షన్లో ఉంటుంది, E1 అనేది PB డైరెక్షన్లో ఉంటుంది. అంటే E2 అనేదేమో ఈ డైరెక్షన్లో ఉంది, E1 అనేదేమో ఈ డైరెక్షన్లో ఉంది. సో ఈ రెండు ఈక్వేషన్ ఉపయోగించి మనం నెట్ ఎలక్ట్రిక్ ఫీల్డ్ ఎలా అనుకున్నామో చూద్దాం. Children, up to now what we discussed, what is E1 and what is E2. Now we have to go for resultant electric field intensity at the point P. That is given by what is resultant electric field intensity. That is how we can write E is equals to E1 plus E2. E1 plus E2. What is E1? This is the E1 and this is E2. Now substitute here. E is equals to what is this one? 1/4 pi epsilon naught q by R minus A whole square plus of 1/4 pi epsilon naught minus q by R plus A whole square. Here plus of minus minus. Therefore E is equals to what, right? 1/4 pi epsilon naught q by R minus A whole square minus 1/4 pi epsilon naught q by R plus A whole square. So children, in these two terms 1/4 pi epsilon naught and q is the common. Clear? So we are taking the common. This is the plus and this is the minus. Plus of minus minus. That's why we wrote minus here. So here we have to take q is the common. Q by 4 pi epsilon naught is the common. Then what you have to write? E is equals to 1/4 pi epsilon naught, q is common. Then what you have to write? 1/R minus A whole square minus 1/R plus A whole square. Here we write E is equals to q by 4 pi epsilon naught of, here R minus A whole square, R plus A whole square. So LCM is R minus A whole square into R plus A, now R minus A whole square into R plus A whole square. Then what, right children? LCM R plus A whole square minus R minus A whole square. R plus A whole square, R minus whole square. Children, it is in the form of like this, A plus B whole square minus A plus B whole square minus A minus B whole square, A minus B whole square, like that. Then it is equation is what? 4AB. Clear? So it is in the form A plus B whole square minus of A minus B whole square. The formula is what? 4AB. That's why we have to write E is equals to q by 4 pi epsilon naught of 4 into this is A and this is B. What do you write? 4A R by, I am writing like this, R plus A into R minus A whole square. Denominator can be written as R plus A into R minus A whole square. Why? Because children, x square y square it is there. How we can write? Xy whole square, like that. So R minus A is x square into y square. Then what write? Xy whole square, like that. Here what write? E is equals to q by 4 pi epsilon naught into 4A R by, it is in the form of A plus B into A minus B. Then what you get? R square minus A square whole square. So this is the, here E is equals to q by 4 pi epsilon naught 4A R by R square minus A square whole square. Why? Because it is in the form of A plus B into A minus B. That is equals to what? A square minus B square. So in that formula, children, here, so we need some space, that's why I am erasing this one. Here what do you write? E is equals to, here 4A already is there, that is can be written as 2A into Q into 2R. 4A R ఉంది కదా, దీనిని నేను 2 into 2A రాస్తున్నా, లేదా 2A into AR రాస్తున్నా. అప్పుడు ఏమవుతుంది? లైక్ దిస్ 2AQ into by 2AQ into 2R by, what you have? 4 pi epsilon naught R square minus A square whole square. So children, already we discussed, what we discussed? 2A into Q means what? Dipole moment. What we have? Dipole moment. So therefore we know that 2A into Q is what? P, dipole moment. Then the equation can become as like this. E is equals to P into or 2P into R by 4 pi epsilon naught R square minus A square whole square. So children, this is the expression for the electric field intensity at a point P on the axial line. At a point P on the axial line. E is equals to 2pr by 4 pi epsilon naught R square minus A square is what? This is the expression for electric field intensity at a point on the axial line. Children, here we have one special case, it is there. That is what you have to say. From that figure, what you have to say? Simply here note, in the diagram what you have to say? R is so greater than A. R is so greater than A. That means what? The dipole is very shorter. Leda for short length of dipole, short dipole. Clear? R is so greater than A. When R is so greater than A, almost all we neglect the A. Then what do you write? E axial is equals to 2pr by 4 pi epsilon naught. We can neglect A. Then what do you write? R square whole square. Then what you get? E axial is equals to 2pr by 4 pi epsilon naught R to the power of 4. R once cancel. Here what? One time cancel. Then what you get? So what do you get, children? Simply here we are writing like this. Here what do you get? E axial is equals to what do you get here? 2p by 4 pi epsilon naught R cube. So this is the expression for electric field intensity at a point on the short dipole, and this is the expression for electric field intensity at a point on the axial line of a dipole that should be having some more length, and this is for shorter dipole. So this is the 4 marks question, children. So when you have to write the notes, they have to pause the video and prepare the notes. So this is about the children electric field intensity at a point on the axial line. So children, if you can understand this one, like, share, comment the video and subscribe my channel to get all the notifications. My request is suggest my channel to your friends also. Okay, thank you.